Let's take a look at this question. The product of the first and the fifth terms of an AP is 45. The first term there is representing T1. Recall that our Tn, that is generally now, Tn is the same thing as A plus n minus 1d, where A is our first term and n is the number of terms. So our T1 from the question now, which is our first term, is denoted by A, while our T5, which is the fifth term, according to the formula, will be denoted by A plus 5 minus 1, which is 4D. Also, they said that the sum of the second and the fourth term, the second term is our T2, which is the same thing as A plus D, according to the formula. And also our T4, which is the fourth term, which is A plus 3D. Now, when you have constructed these four terms, then follow the instruction given by the question. The product of the first and the fifth term is 45, meaning that T1 times T5 is equal to 45. Which means that T1 times T5 gives you 45. And from what we deduced, T1 is A and T5 is A plus 4D, which is the same thing as 45. We call this the first equation. Also, we are given that T2, as the sum of T2 and T4, is equal to 18, where we know that our T2 is A plus D and our T4 is A plus 3D, which is equal to 18. We can also call this equation 2. You can still simplify this further by collecting the like terms, which will result to A plus, that is 2A plus 4D, D plus 3D equals 18. Now, how do you solve these two equations simultaneously? From the second equation, from equation 2, we can see that when we make D the subject of the formula, our D is the same thing as 18 minus 2A over 4. So we know that the value of D now is 18 minus 2A over 4. So therefore, let us impute this in equation 1. Put D in equation 1. So if D is equal to 18 minus 2A over 4, and our equation 1 is A times A plus 4D equals 45. When you expand this, you have A squared plus 4AD equals 45. And our D is 18 minus 2A. So we can say that we have A squared plus 4A into D, which is 18 minus 2A, all over 4. Everything equals 45. Now, 4A times this 4 is common to both. They can divide each other. So we'll be left with A squared plus A into 18 minus 2A equals 45. And if you expand further, you'll be having A squared plus 18A minus 4 minus 2A squared equals 45. When you collect like terms, you have this equation minus A squared plus 18A minus 45 equals 0. Now, if you solve these equations, you have the value of A to be A equals 15 or A equals 3. Try to solve and change it to something like this. If you take everything to the right hand side, you have A squared minus 18A plus 45 equals 0. I believe you can solve this. So when you solve this, the value of A would be 15 or 3. So when you now have this, you go back to this equation. Since we know the value of D to be 18 minus 2A over 4. Since we have two values of A, we can say that when the value of A equals 15, D will give us 18 minus 15 times 2, that is A times 2 over 4, where D is 18 minus 30 over 4. 18 minus 30 is minus 12 over 4, and our D is minus 3. Also, when A is equal to 3, we have our D to be equals to 18 minus 2 into 3 over 4, which is the same thing as 18 minus 6 over 4, which is equal to 3. So from this solution, we can see that we have two first terms and we have two common differences. So in this case, we have two terms as well. Or what is the sequence going to look like? So it means if the first term, when A is equal to 15, our D is equal to minus 3, and we are asked to list out the first three terms of the sequence. So it means if the first term is 15, the next term will be 15 minus 3, which is 12. And the next term to it will be 12 minus 3, which is 9, and so on. Then when the first term is 3, our common difference is 3, which means that the sequence will be the first term, which is 3, plus the next term to it, which is 6, plus 3, which is 9, and so on. So this gives us the two possible sequences that will be generated from the given questions.